Hello there, and welcome to the Dozing Explorer. I am so glad you have found this quiet space tonight. Let the world outside soften and fade as you settle into a place of stillness and comfort. There is a gentle, quiet journey waiting for you here, a place to let the weight of the day simply dissolve into the background. Allow your body to feel heavy and supported, and let each breath you take be a little slower, a little deeper than the one before. There is nothing you need to do and nowhere else you need to be. Tonight, we will not be taking a direct path. We will not be solving equations or following a rigid lesson plan. Instead, we are going to drift into the soft and beautiful patterns of chaos theory. We will not be studying, but simply observing, as if watching the slow, swirling patterns of smoke in a still room, or tracing the delicate branching veins of a leaf. We will listen for the quiet whispers of order that hide within the seemingly random, and watch as the simplest of beginnings unfolds into the most intricate and wonderful of designs. This is not a lecture, but a lullaby about the universe's hidden poetry, the gentle dance that connects all things. We will imagine the profound journey of a single drop of rain as it finds its way to the ocean, and how the flutter of a butterfly's wing can begin a story that unfolds across a continent. We will wander through the infinite feathery coastlines of fractals, patterns that hold an entire world of detail within their smallest part, like a secret blueprint for clouds and mountains and trees. We will feel the gentle, invisible currents that guide the weather, a system so vast and interconnected that it can never be perfectly known, yet so beautiful in its endless flowing dance. It is a world of quiet connections, of subtle influences, and of profound unfolding beauty, waiting to hold your mind as you begin to drift. And just before we begin our drift, if you find that these quiet patterns and gentle explorations help to soothe your mind, you might consider liking and subscribing. It is a small, quiet gesture that helps other weary travelers find their way to this restful space, joining our community of explorers who seek comfort in wonder. There is no need to do anything at all right now. It is just a soft thought to hold for a moment, before letting it go like a seed on the wind. For now, your only task is to rest. There is nothing you need to understand and nothing you need to remember. Let my voice be a gentle, rhythmic presence in the background, a soft current to drift upon. If your mind wanders through its own swirling patterns, that is perfectly fine. Let it drift. If sleep comes to find you, that is wonderful. Just allow yourself to soften, to let go, and to be carried along as our journey into the beautiful chaos begins. The gentle flutter of a butterfly's wings in Brazil can, in time, set off a tornado in Texas. This is the most famous whisper of chaos theory, an idea known as sensitive dependence on initial conditions. It does not mean that the butterfly's wings contain the immense power of the storm, but rather that in a vast and interconnected system like our atmosphere, the smallest, most imperceptible disturbance at the very beginning can ripple outwards, growing and branching and gently influencing the great currents of the air. That tiny puff of wind, a motion no larger than a sigh, might be the one deciding factor that shifts a weather front a few inches, which in turn causes a larger shift of a few feet and then a mile, until weeks later, the final outcome of a vast weather system is completely different than it would have been, all because of one tiny, forgotten moment. It is a quiet reminder that the world is a tapestry of such delicacy that a single dropped stitch can alter the entire pattern. The universe is listening to its smallest and most silent whispers. Within the heart of a chaotic system lies a beautiful, invisible shape that its journey will never escape. This ghostly blueprint is called a strange attractor, a concept that gives a beautiful form to seemingly random behavior. Imagine a single mote of dust dancing in the warm air above a candle. Its path seems utterly unpredictable from one moment to the next, a flurry of chaotic motion. Yet, if you were to trace its journey for 1,000 years, you would find that its path never truly repeats, but it also never wanders off into the far corners of the room. It is forever confined to a specific, looping, and infinitely complex pattern in the air. The famous Lorentz attractor, the first of its kind to be discovered, looks like the delicate, overlapping wings of a butterfly, a shape that the weather system it describes will trace forever without ever landing on the exact same point twice. It is a path of infinite variety contained within a finite and beautiful space. It is a portrait of a system that is forever wandering but never truly lost. A single fern frond holds the perfect blueprint for the entire fern within its smallest part. This is the quiet magic of fractals, the intricate and repeating patterns that are the visual language of chaos theory. A fractal is a shape that possesses the quality of self-similarity, meaning that if you were to zoom in on any tiny piece of it, you would discover a smaller yet recognizable version of the whole structure. Think of the slow, patient branching of a tree, where each large branch sprouts smaller branches that mimic the shape of the larger one, all the way down to the tiniest twigs reaching for the sky. Or consider the jagged, crenellated edge of a single snowflake, where each crystalline arm is itself decorated with smaller, similar arms, repeating a simple idea into endless complexity. Nature uses this simple rule of repetition to build the most intricate designs of coastlines, clouds, and lightning bolts from a single, recurring thought. The universe writes its grandest signatures with a single, repeating letter. 4. The coastline of a country is a line of infinite length, held within a finite and bounded space. This gentle paradox reveals the strange and wonderful nature of fractal geometry in our world. If you were to measure the coast of Britain with a yardstick a mile long, you would arrive at one answer for its length. But if you were to use a smaller yardstick, perhaps 1 foot long, you would be able to capture more of the small nooks and crannies, the tiny bays and inlets missed before, and your final measurement would become longer. If you used a ruler only an inch long, it would be longer still. As your measuring tool becomes smaller and smaller, the measured length of the coastline grows and grows, approaching an infinite length. This is because a coastline is a natural fractal, possessing a similar roughness and complexity no matter how closely you look. It is a line that you can walk along, yet its true length remains immeasurable, a secret held in its endless detail. Nature's edges are not simple lines, but endless, feathery shores. 5. Chaos is not the same as randomness, but rather a hidden and profound form of order. A truly random system, like the static on an old television screen, has no memory and no underlying pattern. Each point is entirely independent of the last. A chaotic system, however, is what we call deterministic. This means that if you could know its starting position with impossible, perfect precision, you could, in theory, predict its entire future. The problem is that perfect precision is impossible. The system is so exquisitely sensitive that any rounding error, any measurement smaller than an atom, is enough to send the future of the system down a completely different path. Chaos, then, is not the absence of rules. It is the surprising and beautiful consequence of simple, unbreakable rules being followed with perfect fidelity, creating a world that is at once patterned and forever new. It is the intricate dance of a universe that follows its own laws perfectly. 6. The steady, rhythmic dripping of a faulty faucet can hold all the secrets of chaos within its gentle pattern. At first, the drips may fall in a simple, predictable rhythm, like a perfectly kept clock. But as you slowly turn the tap, increasing the flow rate just a little, the rhythm will change. Suddenly, the time between drips will begin to alternate between a long gap and a short one, a simple 2-step beat. Turn it a little more, and this beat may split into a 4-beat pattern, and then an 8-beat pattern, a cascade of increasing complexity. And then, with one final tiny adjustment, the pattern dissolves completely. The drips begin to fall in a sequence that seems entirely random, a chaotic pattern that never repeats. Yet this is not randomness. It is a simple, mechanical system following simple physical laws that has crossed a quiet threshold into a world of infinite and beautiful complexity. A universe of possibility can hide in a single drop of water. 7. A simple mathematical equation can contain an entire universe of infinitely complex behavior. Consider the logistic map, an equation so simple you could solve it on a pocket calculator. It was first designed to model the way a population of animals might grow and shrink over generations. If you put in a number, it gives you a new one, which you then feed back into the equation over and over. For some starting numbers, the population settles into a stable, predictable level. For others, it oscillates between 2 values, a boom and a bust. But as you adjust a single parameter in the equation, something amazing happens. The system begins to bifurcate, splitting from 2 values to 4, then 8, then 16, until it suddenly breaks into full chaos, where the population seems to fluctuate without any discernible pattern at all. From the simplest of rules, a world of unpredictable richness emerges. The most complex stories are often born from the simplest of sentences. 8. The beautiful feathery diagrams of a system entering chaos show a waterfall of splitting paths. This visual representation of a system like the dripping faucet or the logistic map is called a bifurcation diagram. Imagine a single, gentle river flowing steadily along. This represents a stable, predictable state. As we change a parameter, like the flow of water, this river suddenly splits into 2 distinct streams. This is the first bifurcation. As we continue, each of these 2 streams splits again, creating 4 parallel paths. This cascade continues, the paths splitting and splitting again faster and faster, like the branches of a tree growing in fast motion. The diagram becomes a beautiful feathery shape, dense with an infinity of possible paths. And then, at a certain point, all these distinct streams merge into a great, wide, turbulent sea of chaotic behavior, a space where the system can wander freely. It is the gentle map of a river flowing into a wild and boundless ocean. 9. The swirling patterns of smoke rising from a candle are a quiet painting of chaos in motion. Watch the smoke as it first leaves the wick. For the first few inches, its path is smooth and predictable, a straight, unwavering line of gray. This is called laminar flow, a state of simple order. But then, as it rises and cools, it reaches an invisible boundary. The smooth line suddenly breaks, dissolving into a dance of intricate and beautiful whirls, eddies, and plumes. This is the transition to turbulence, a classic example of a chaotic system. The motion is still governed by the simple laws of fluid dynamics, but the behavior has become so complex and sensitive that you could never predict the exact shape of the plume from one moment to the next. You are watching a quiet and orderly system gracefully blossom into infinite complexity. The air itself is an artist, painting with invisible currents. Nature seems to thrive in a delicate balance, precisely on the edge of chaos. This is a profound and beautiful idea, that the most interesting, adaptive, and lifelike behaviors in the universe occur in a special region, a kind of creative frontier between rigid, frozen order and completely formless, gaseous randomness. A system that is too orderly is static and unchanging, like a crystal. A system that is too random is noisy and incoherent. But right on the border between them, at the edge of chaos, a system has enough structure to maintain its integrity, but also enough flexibility to adapt, evolve, and create novel patterns. Life itself, from the firing of neurons in the brain to the complex dynamics of an ecosystem, seems to exist in this fertile and dynamic space, forever dancing on the boundary of surprise. It is the narrow shoreline between a sea of turmoil and a land of stillness. The weather is a perfect example of a system we can understand but never perfectly predict. We know the fundamental physical laws that govern the atmosphere, the equations for heat, pressure, and moisture. In principle, if we could measure the exact state of every single molecule of air on the planet at one instant, we could calculate the weather for all future time. But this is an impossible task. We can only ever measure a limited number of points, and each measurement has a tiny margin of error. In a chaotic system like the weather, these tiny, unavoidable uncertainties are all it takes. They are the metaphorical butterflies. They grow and amplify over time so that a weather forecast that is very accurate for tomorrow becomes less accurate for the next day, and by 2 weeks out, it is no more reliable than a random guess. We can know the symphony's score, but we can never know the exact performance. The atmosphere is a story that is always improvising. 12. A strange attractor carves out a valley in a landscape of possibilities, and the system can never climb out. Imagine a vast, invisible landscape with mountains and valleys representing every possible state a system could be in. When you start the system, it is like placing a small marble somewhere on this landscape. The system will then begin to roll downhill, following the contours of the terrain, eventually settling into the deepest part of a valley. This valley is the attractor. For simple systems, the valley is just a single point, a state of perfect equilibrium. But for chaotic systems, the valley is a strange and complex shape, a looping, winding canyon with infinite paths. The system will roll along the floor of this canyon forever, exploring its intricate geography without ever repeating its path and without ever having enough energy to climb back out of the valley walls. It is a gentle confinement to a world of infinite exploration. 13. The Mandelbrot set is an infinitely complex shape born from an impossibly simple rule. This iconic fractal, which looks like a beautiful, bumpy beetle decorated with flames and spirals, is generated by one of the simplest equations imaginable. You take a number, perform a simple calculation, and if the result flies off towards infinity, that starting number is not in the set. If the result stays contained, bouncing around forever without escaping, it is part of the set. That is the entire rule. Yet from this binary choice, to escape or to remain, emerges a shape of literally infinite complexity and detail. If you zoom in to the fuzzy, intricate boundary of the Mandelbrot set, you will find smaller, distorted copies of the main shape, sprouting off into spirals and tendrils. No matter how deep you zoom, for miles and miles of magnification, you will continue to find new and beautiful patterns, forever. It is an entire universe of art hidden inside a single, simple question. 14. A system can remember its past without ever repeating it. This is one of the beautiful qualities of a chaotic system. Its state at any given moment is a direct and determined consequence of the state it was in a moment before. Its present holds the memory of its entire history. However, because of its sensitive nature, it is almost impossible for it to ever return to the exact same state twice. Think of a piece of driftwood being carried along in a swirling, turbulent river. Its path is dictated by the currents, a continuous and flowing journey. It might circle back near a place it has been before, but the chance of it passing through the exact same point with the exact same orientation, moving at the exact same speed, is practically zero. It is a system that is always visiting new territory, even as it travels within the familiar landscape of its attractor. It is a journey of endless novelty, guided by perfect memory. 15. The intricate patterns on a seashell are a frozen record of chaotic growth. As a mollusk grows, its shell extends by adding new material along its leading edge. The pattern of pigments that are deposited onto this new material is often governed by a simple set of rules, a chaotic system of activation and inhibition. A tiny random fluctuation in the animal's chemistry can be enough to start a new line of color, which then propagates and interacts with other lines as the shell grows. The result is the beautiful and complex patterns we see, stripes, zigzags, and mottled spots that seem artistic and designed, yet are the product of a simple, sensitive process. Each shell is a unique physical history book of the chaotic dynamics that governed its creation, a pattern that is ordered but will never be seen again in the exact same way. It is a lifetime of quiet decisions written in stone. 16. The boundary between order and chaos is often a beautiful, fractal shoreline. When you look at a diagram of a chaotic system, like the Mandelbrot set, the regions of stability are often solid, simple shapes. These are the calm lakes and continents of predictability. The regions of chaotic behavior are also often uniform in their texture. But the coastline between these two territories, the place where the system transitions from one state to another, is almost always a place of incredible complexity and beauty. It is a fractal shoreline with endless bays, peninsulas, and islands. This means that a tiny, tiny change in your starting position can cause you to cross this intricate coastline, moving you from a world of perfect stability to one of beautiful chaos in an instant. This delicate, interwoven boundary is where the most interesting behavior is often found. It is where the land of order meets the sea of wonder. 17. The branching of a lightning bolt is a fractal path of least resistance being discovered in real time. When a bolt of lightning descends from a cloud, it does not follow a pre-planned route. It feels its way downwards moment by moment. It sends out small exploratory branches called leaders, which ionize the air ahead. The path that finds the easiest, most conductive route to the ground is the one that grows, and then it too branches out, repeating the process. The result is the iconic, jagged, tree-like structure, a perfect fractal. It is a picture of a chaotic process unfolding in a fraction of a second, a search pattern for the most efficient way to connect the cloud and the ground.
Every single lightning strike is unique, a one-of-a-kind solution to a complex electrical problem drawn against the sky in a flash of light. It is nature's instantaneous branching signature. 18. The rhythm of a healthy heart is not a perfectly regular beat, but a subtly chaotic one. While we might think of a healthy heart as beating like a perfect metronome, studies have shown that the time between heartbeats naturally fluctuates in a complex, chaotic pattern. A heart that beats with perfect, machine-like regularity is often a sign of a problem, a system that has become too rigid and is less able to adapt to changing demands. The subtle chaos of a healthy heart rhythm allows it to be more flexible and responsive, able to adjust quickly to exercise, rest, or surprise. It is another example of a system thriving on the edge of chaos, using a deep and complex variability to maintain a state of resilient health. The rhythm of life itself is not a simple tick-tock, but a deep and complex music. 19. Chaos theory reveals a universe that is far more creative and alive than a simple clockwork machine. Before these ideas, one of the prevailing images of the universe was that of a giant, predictable machine, set in motion at the beginning of time and following a deterministic path forever. If you could know the position of every gear, you could know the entire future. Chaos theory does not remove the deterministic nature, but it reveals that even with simple, clockwork-like rules, the universe can produce behavior that is endlessly creative, surprising, and impossible to predict in practice. It gives us a picture of a universe that is not a static script being performed, but a constant, ongoing act of creation, where the simplest ingredients can combine to produce infinite novelty. It is a universe that can always surprise itself. 20. The Great Red Spot on Jupiter is a storm of beautiful, chaotic stability that has lasted for centuries. This colossal, swirling anticyclone, a storm wider than the entire planet Earth, is a magnificent example of a self-organizing structure within a chaotic fluid system. The turbulent atmosphere of Jupiter, with its powerful jet streams and rising heat, provides the energy that feeds the storm. Yet, out of this chaos, the Great Red Spot has emerged and persisted, a stable island in a sea of turbulence. Its internal dynamics are a chaotic dance of whirls and eddies, constantly changing and evolving, but the overall structure remains. It is a testament to how chaotic systems can give birth to patterns of incredible longevity and resilience, finding a point of stable complexity and holding onto it for ages. It is a quiet, crimson jewel in a sea of celestial turmoil. 21. The stock market's unpredictable fluctuations are a reflection of a vast, chaotic social system. The price of a stock from one day to the next is influenced by a near infinite number of factors: economic reports, political events, investor sentiment, and countless individual decisions. This complex, interconnected web of influences makes it a classic chaotic system. While there are underlying trends and patterns, the system is so sensitive to new information and small shifts in collective mood that precise long-term prediction is impossible. A tiny piece of news, the butterfly's wing, can ripple through the system, causing waves of buying or selling that were entirely unforeseen. It is not random, but it is a system whose complexity is born from the simple repeated actions of millions of people, each with their own hopes and fears. It is the chaotic rhythm of a collective human heartbeat. 22. A computer can generate a perfect fractal image, but it can never finish drawing it. Because a fractal contains infinite detail, no matter how powerful the computer, it can always zoom in further and find more complexity to render.
A human artist might draw a picture of a tree, but at some point they must decide they have drawn the last leaf, the final twig. A computer drawing a fractal tree, however, could continue forever, drawing smaller and smaller branches on smaller and smaller twigs, ad infinitum. The process of exploring a fractal is a journey with no end. It is a window into a kind of mathematical infinity, a finite shape that holds an endless amount of information and detail within its boundaries. It is a quiet lesson in the difference between a simple rule and its endless consequences. 23. The orbits of planets in our solar system over very long timescales are gently and subtly chaotic. For centuries, we imagined the solar system as a perfect piece of cosmic clockwork, with planets following perfectly predictable paths forever. And over the course of a human lifetime, this is almost true. But over millions and billions of years, tiny, gentle gravitational nudges between the planets begin to add up. These small interactions make the system chaotic. We can't be certain, for instance, what the exact eccentricity of Mars's orbit will be in 100 million years. A tiny change in our current measurements could lead to a large difference in that far future prediction. The solar system is not a perfect clock, but a living, dynamic system, a slow, majestic dance whose long-term choreography is beautifully and fundamentally unknowable. It is a dance of gentle, gravitational whispers. 24. Chaos provides a bridge between the simple, microscopic laws of physics and the complex, messy world we see. We know that the world is governed by simple, elegant physical laws at the level of atoms. But when we look around, we see complexity everywhere. The turbulent flow of a river, the intricate shape of a cloud, the unpredictable patterns of life. Chaos theory shows us how the latter can emerge from the former.
It demonstrates how vast collections of simple components, all following simple rules, can spontaneously organize themselves into complex, unpredictable, and beautiful macroscopic systems. It is the missing link that allows a universe of simple ingredients to give rise to a world of such rich and wonderful texture. It is the secret recipe for how to build a forest from the physics of a single atom. 25. The pattern of frost on a window pane is a fractal story of a freezing night. As the temperature drops, tiny, supercooled water droplets on the glass need a place to begin freezing. The first crystal forms at a point of imperfection, a tiny speck of dust. This crystal then grows, and its arms branch out across the glass. The shape of these branches creates a new landscape, influencing where the next crystals are most likely to form. The process is chaotic and sensitive to the tiniest variations in temperature and humidity across the pane. The result is the beautiful, feathery, fern-like patterns that greet us on a cold morning. Each window is a unique canvas, and each night of frost paints a different, unrepeatable masterpiece, a silent record of the cold's gentle creeping journey. It is the quiet, crystalline art of a winter's night. 26. In a chaotic system, two almost identical starting points will eventually lead to vastly different futures. Imagine two small, identical paper boats placed in a gentle, flowing stream, just a fraction of an inch apart. For the first few feet, their journeys will be almost identical. They will float side by side, following the same currents. But then, one boat might be nudged by a slightly different swirl of water, a tiny eddy that the other boat misses. This small divergence will cause it to enter a different part of the current. A minute later, the boats might be a foot apart. After 10 minutes, one might be caught by the bank while the other has floated far downstream. This is the essence of sensitive dependence. Tiny, unmeasurable differences in the beginning are amplified over time, leading to completely unrelated outcomes. The future is a fan of diverging, beautiful paths. 27. The intricate folds within the human brain vastly increase its surface area, following a fractal-like pattern. The surface of the brain, the cerebral cortex, is where much of our higher thought processing occurs. To fit this large and vital surface into the compact space of the skull, it is crumpled and folded in on itself in a complex pattern of ridges and valleys. This folding pattern, while not a perfect mathematical fractal, exhibits fractal-like qualities. It is a brilliantly efficient, space-filling strategy that allows for a massive number of neural connections in a small volume. It is a brilliantly efficient, space-filling strategy that allows for a massive number of neural connections in a small volume. It is another example of nature using a simple principle of repeating, wrinkled geometry to solve a complex packaging problem, creating the physical landscape upon which our thoughts can wander. The terrain of our own mind is a beautiful, folded country. Turbulence in a fluid is the chaotic dance of countless interacting water molecules. When water flows slowly and smoothly in a pipe, its motion is simple and predictable. But when the flow becomes turbulent, it transforms into a complex, churning chaos of eddies and vortices on all different scales. We still do not have a complete mathematical theory to describe the details of turbulence. It is one of the great unsolved problems in physics. It is a perfect example of how the simple, known laws governing the behavior of individual molecules can lead to a collective behavior of such immense complexity that it defies our attempts to capture it in simple equations. It is the universe showing us that even in the most familiar substances, like water and air, there are deep and beautiful mysteries yet to be solved. It is the wild heart of every river and every wind. 29. The sound of a crackling fire is the audible music of a chaotic process. Each crackle and pop is the sound of a pocket of gas or sap in the wood suddenly heating up and bursting. The location and timing of these tiny events are unpredictable, governed by the complex, chaotic structure of the wood and the turbulent flow of heat from the flames. The resulting sound is a pattern that is rich and complex, never repeating, but always sounding like a fire.
It is not pure random noise, it has a structure and a rhythm. Listening to a crackling fire is a deeply soothing experience, perhaps because we are listening to a natural, chaotic system that is balanced between predictability and surprise, a sound that is always familiar, yet always new. It is the gentle, chaotic song of warmth and release. 30. Even the gaps in the rings of Saturn are sculpted by the subtle, chaotic dance of gravity. The beautiful rings of Saturn, which look so solid and uniform from a distance, are made of countless small particles of ice and rock, each in its own individual orbit. The distinct gaps in these rings are not empty by chance. They are often created by orbital resonances with Saturn's many moons. A particle orbiting in a gap would receive a regular, repeated gravitational tug from a moon, destabilizing its orbit and eventually flinging it into a different path. These resonant interactions can be highly chaotic, creating sharp, well-defined edges and intricate, delicate structures within the rings over millions of years. The grand, silent architecture of the rings is a masterpiece sculpted by the patient, persistent whispers of chaotic gravitational nudges. 31. A strange attractor has a fractal structure, meaning it is a line of infinite length packed into a finite space. If you were to take the looping butterfly wing shape of the Lorentz attractor and zoom in on one of its lines, you would find it is not a single line at all.
It is actually composed of many finer lines packed closely together. If you zoomed in on one of those finer lines, you would find it too is made of even finer strands. This continues forever. It means that the path the system traces is not just a simple one-dimensional curve. It has a fractal dimension, a number that is not a whole number, something between a simple line and a flat plane. It is a shape of ghostly, in-between dimensionality, a line so complex and crinkled that it begins to take on the properties of a surface. It is a thread that can fill a whole world. 32. The distribution of stars in a galaxy shows fractal patterns on a colossal scale. When we look at a map of a galaxy, the stars are not spread out uniformly like a smooth gas. They are clumped together into star clusters, which are themselves part of larger spiral arms or galactic bars. Studies of these distributions have shown that they have a fractal character over a wide range of scales. The way stars cluster together looks similar whether you are looking at a small region or a much larger one. This suggests that the chaotic and turbulent process of gravitational collapse, the process that forms stars from vast clouds of gas and dust, leaves behind its fractal signature on the very structure of the galaxy. The great cities of stars are built with the same beautiful rough geometry as a cloud or a mountain range. 33. Chaos theory teaches a kind of humility in the face of nature's complexity. It shows us that even if we have the perfect rulebook for a system, we may never be able to perfectly predict its behavior. It places a fundamental limit on our knowledge. This is not a limit born of ignorance, but one born of the nature of the system itself. There will always be a butterfly we didn't account for, a measurement that wasn't quite precise enough. This invites us to approach the world not as a problem to be solved and perfectly controlled, but as a dynamic and creative process to be observed, appreciated, and wondered at. It encourages a relationship with the world based on awe rather than a desire for complete mastery. We are not the masters of the dance, but simply fellow dancers. 34. The intricate branching patterns of blood vessels in our bodies are life-saving fractals. To deliver oxygen and nutrients to every single cell, our circulatory system needs to be an incredibly efficient space-filling network. It achieves this through fractal branching. A large artery branches into smaller arteries, which in turn branch into even smaller arterioles, and finally into a fine mesh of capillaries that reaches every tissue. This fractal design ensures that no cell is ever too far from a blood supply, while minimizing the volume taken up by the vessels themselves. It is a perfect solution to a complex biological engineering problem. Another example of life discovering the profound efficiency and elegance of fractal geometry to sustain itself. The river of life within us flows along a beautiful, branching, and intricate path. 35. A small island in a chaotic sea can represent a pocket of profound stability. Within a bifurcation diagram, amid the wide regions of chaotic behavior, you can sometimes find tiny, narrow windows of order. These are places where, for a very specific set of parameters, the system suddenly snaps back into a simple, predictable pattern, like a calm and quiet island in the middle of a turbulent ocean.
A tiny change in either direction would plunge the system back into chaos. But in this one specific place, a delicate stability emerges. It is a reminder that the relationship between order and chaos is not a simple one-way street. The two are deeply interwoven, with pockets of one always hiding within the heart of the other.
Even in the wildest of storms, there can be a place of perfect, quiet calm. 36. The act of folding a piece of dough creates chaotic mixing with beautiful efficiency. When a baker kneads bread, they are performing a simple chaotic process. They stretch the dough out, fold it back on itself, and press it down. This simple sequence of stretching and folding, repeated over and over, is an incredibly effective way to mix the ingredients. Two particles of flour that start out very close together will, after just a few folds, end up in completely different parts of the dough. This is the same principle of sensitive dependence at work. This process creates the even, consistent texture of the bread, transforming a lumpy, uneven mass into a smooth and uniform whole through a simple, repeated, chaotic action. It is a gentle, everyday form of creative chaos. 37. A pinball machine is a small, contained universe of chaotic trajectories. When you launch the silver ball, its initial path is determined by your simple action. But as soon as it strikes the first bumper, its future becomes exquisitely sensitive. A difference of 1/1000th of an inch in where it hits will send it on a completely different path. It will ricochet through the machine, its journey a unique and unrepeatable dance between gravity and the rebounding bumpers. While the rules are simple and the space is small, you can never truly predict the ball's final path. Each game is a new experiment in chaos, a brief and beautiful illustration of how simple rules and a sensitive dependence on initial conditions can create a world of endless shimmering variety. Each game is a new, unwritten story. 38. The beautiful, iridescent patterns in a soap bubble are a fleeting map of chaotic fluid dynamics. The surface of a bubble is a thin film of soapy water, constantly in motion. The colors we see are caused by the interference of light reflecting off the front and back surfaces of this film. As the water drains downwards due to gravity and swirls in response to tiny air currents, the thickness of the film changes from moment to moment. This creates the beautiful swirling patterns of rainbow colors that seem to drift across the bubble's surface. You are watching a real-time visual display of a chaotic system, a delicate and beautiful dance that lasts for only a few moments before it vanishes. It is a fragile, shimmering portrait of the beauty of transient chaos. The jagged, shattered pattern of a broken piece of glass is a fractal of fracture. When glass breaks, the crack does not propagate in a simple straight line. The main crack will often branch off into smaller cracks, and those smaller cracks will branch off again. The pattern is influenced by the chaotic distribution of tiny, microscopic flaws within the glass itself. The result is a fractal pattern of breakage, a web of sharp angles and branching lines. Like lightning, it is the record of a high-speed chaotic process, a story of stress and release told in a network of jagged, self-similar lines. The pattern is different every single time, a unique signature of a single catastrophic moment. The best path through a forest is often a winding, chaotic one. If you were to try and walk in a perfectly straight line through a dense forest, you would find it almost impossible. You would constantly be forced to deviate, to walk around a tree, to step over a fallen log, to avoid a patch of thorns. Your final path would be a complex, meandering line, a trajectory dictated by the chaotic and beautiful placement of obstacles. This is often true in life as well. The most direct path is not always a straight line, but one that responds and adapts to the complex landscape it must travel through. The most graceful journey is not one of rigidity, but one that knows how to gently bend and flow. A winding path is often the most honest one. A chaotic system explores its own possibilities in a wonderfully efficient way. Because a chaotic system never repeats the same state twice, but is confined to its strange attractor, it is constantly exploring new combinations and possibilities within its own boundaries. This makes chaotic dynamics a powerful tool for problem solving and creativity. It is a way of searching a vast landscape of possibilities without getting stuck in a rut or wandering off into unproductive territory. It is a model for a creative process that is both disciplined and free, one that can generate endless novelty while remaining true to its own underlying character and form. It is the perfect balance between exploration and focus. 42. The rings that form in a coffee cup when a drop of milk is added show the unfolding of a chaotic fluid system. When the drop hits the surface, it creates a plume that rises and folds over on itself, creating intricate, swirling patterns. This process, known as Rayleigh-Taylor instability, is a chaotic one. The exact shape of the beautiful, billowing clouds of white in the dark coffee is unrepeatable. A tiny difference in the height of the drop or the temperature of the coffee will result in a completely different, yet equally beautiful pattern. For a few brief seconds, your coffee cup becomes a small laboratory for observing the beautiful, creative, and gentle unfolding of chaos. It is a fleeting moment of cosmic art in a simple daily ritual. 43. The phase space of a system is the imaginary landscape where its journey takes place. To understand a system's dynamics, scientists often map it not in physical space, but in an abstract space where each axis represents a different property, like position and velocity. A swinging pendulum, for example, can be described by its angle and its speed. Its journey in this phase space would be a simple, predictable loop.
But the journey of a chaotic system in its own, more complex phase space is the path that traces out the strange attractor. It is a way of turning a complex set of numbers and changes into a single geometric shape, allowing us to see the hidden order and beauty in a system that might otherwise seem like a formless tangle of data. It is a way of seeing the invisible ghost that guides the machine. 44. The timing of geyser eruptions, like Old Faithful, is not perfectly regular, but subtly chaotic. For a long time, the eruptions of this famous geyser in Yellowstone were thought to be as predictable as a clock. But careful long-term measurements have shown that the interval between eruptions is not constant. It fluctuates according to a complex, chaotic pattern. The system is a giant underground plumbing network of heated water and steam, and its dynamics are sensitive to small changes in pressure and temperature. The geyser's rhythm is another beautiful example of a natural system that appears regular on the surface, but whose deeper truth is one of gentle, bounded, and beautiful chaos. Its faithfulness is not that of a clock, but of a living, breathing system. 45. The boundary of the Mandelbrot set is a place of infinite possibility. Right on the very edge of this famous fractal, something magical happens. This is the boundary between the numbers that escape to infinity and the numbers that are trapped forever. A number chosen from this boundary will produce a sequence that is chaotic, never settling down, but never escaping either. It will dance on the knife's edge of infinity for all time. This boundary, though it has no thickness at all, contains a richness of information that is greater than all the stable regions inside or the empty regions outside. It is another example of the edge of chaos, a place of infinite creativity and complexity, a delicate shoreline between two great and simple certainties.
The patterns of sand dunes in a desert are a large-scale sculpture carved by chaotic winds. The wind that blows across a desert is a turbulent, chaotic fluid. It picks up grains of sand and deposits them elsewhere. Over long periods, this process creates the vast, beautiful, and ever-changing landscapes of sand dunes. The shape of the dunes, their gentle, sloping windward side, and their steep, collapsing leeward side, is a product of these chaotic dynamics. While individual grains of sand move unpredictably, the collective result is a landscape of profound order and pattern, a frozen snapshot of the wind's invisible currents. The desert is a canvas, and the wind is a slow, patient, and chaotic artist. 47. A simple system of three celestial bodies orbiting each other can be deeply and incurably chaotic. While the problem of two bodies orbiting each other, like the Earth and the Sun, can be solved with perfect precision, the three-body problem has no simple general solution. The complex gravitational interactions between the three bodies create a system that is exquisitely sensitive to their starting positions and velocities. The orbits can evolve into beautiful, braided patterns, or one of the bodies can be suddenly flung out of the system entirely. It is a fundamental reminder that even in the clean, silent world of gravity, the addition of just one more element can be enough to transform a system from perfect clockwork into a world of beautiful, unpredictable chaos. Complexity can be born from the simplest of additions. 48. The way a crowd of people moves through a public square is a living, chaotic system. Each person is following their own simple rules, walking towards a destination, avoiding collisions with others. But the collective behavior of the crowd can be very complex. Lanes of opposing motion can form and dissolve spontaneously. Sudden bottlenecks can appear and then clear.
The movement of one person can have a small, cascading effect on the people immediately around them, which can then ripple outwards through the entire crowd. It is a beautiful, everyday example of a complex, adaptive system, a leaderless dance, choreographed by the simple, moment-to-moment decisions of hundreds of individuals. It is the gentle, flowing geometry of human intention. 49. The genetic diversity within a species is a product of chaotic and unpredictable mutations. The process of evolution is driven by the interplay between genetic variation and natural selection. The variation itself comes from random mutations, small, unpredictable changes in the genetic code. This element of chance, this injection of chaos into the system, is the raw material for all of creation. It is what allows a species to adapt to a changing environment, providing a rich library of possible solutions to new challenges. Without this chaotic element, life would be static and unable to evolve. It is the universe's way of ensuring that the story of life is never finished, that there is always a new, unwritten chapter waiting to be explored. Creation is a conversation between chance and necessity. 50. The universe is not a perfectly predictable clock, but a story that is forever unfolding. This may be the most peaceful and profound insight that chaos theory offers us. It tells us that the future is not a fixed destination that we are simply traveling towards. It is a realm of open possibility, constantly being created by the intricate and sensitive dance of the present. The world is a place of genuine surprise, of endless novelty, and of emergent beauty. The fact that we cannot predict everything is not a failure of our science, but a celebration of the universe's deep, innate creativity. We are privileged to be inside a story that is still being written, a grand, chaotic, and beautiful poem whose next line is always a gentle and wonderful surprise. We are living inside a work of art that is creating itself moment by moment. 51. A murmuration of starlings is a river of 1,000 living bodies flowing with one mind. When you watch a great flock of these birds at dusk, they move not as a collection of individuals, but as a single fluid entity, creating breathtaking, shifting shapes against the sky. There is no leader, no central command. Instead, each bird is following a simple set of rules, reacting only to the movements of its immediate 7 or 8 neighbors. From these simple local interactions, a magnificent and unpredictable global pattern emerges. The flock is a living, chaotic system, hovering on the edge of chaos. It has enough order to remain cohesive, but enough flexibility to react with lightning speed to a predator or a change in the wind. You are watching 1,000 simple decisions give birth to a single, beautiful, and emergent thought, painted in wings across the evening sky. It is a shared, silent, and fleeting mind. 52. The deep and universal number known as the Feigenbaum constant whispers a hidden rule about the road to chaos. As a simple system like the logistic map begins to split from one state to 2, then 4, then 8, the rate at which these new splits appear is not random. The mathematician Mitchell Feigenbaum discovered that the ratio of the intervals between these successive bifurcations is always the same, a constant and universal number, approximately 4.669. This same number mysteriously appears in a huge variety of completely different systems as they approach chaos, from fluid dynamics to electrical circuits. It is a profound hint that the transition from order to complexity is not arbitrary, but follows a deep and hidden mathematical law. It is as if all the different rivers in the world, just as they reach the waterfall, must pass through the same sequence of narrowing gates. It is a secret, universal rhythm on the path to beautiful disorder. 53. The chaotic tumbling of Saturn's moon Hyperion is a testament to the wildness of celestial mechanics. Unlike our own moon, which is nearly spherical and keeps one face tidally locked towards its planet, Hyperion is a strange, potato-shaped and porous body. Its irregular shape and its eccentric orbit, influenced by the powerful pull of the nearby moon Titan, have thrown it into a state of chaotic rotation. It tumbles unpredictably through space, its axis of rotation wobbling so erratically that we can never be sure which part of it will be pointing towards Saturn from one day to the next. Its orientation in the sky is fundamentally unknowable over the long term. Hyperion is a gentle reminder that even the silent, gravitational dance of the heavens is not all perfect clockwork. In the quiet darkness of space, there are wild, untamed dancers, spinning to their own beautiful and unpredictable rhythm. 54. The intricate patterns of lichen growing on an ancient stone are a slow-motion painting of chaotic emergence. Lichen is a symbiotic partnership between a fungus and an alga, and its growth is a slow, patient exploration of a surface. The pattern it forms is not predetermined. It is a response to the microscopic, chaotic variations in the rock's texture, the subtle differences in sunlight it receives, and the random arrival of moisture. It spreads in a fractal pattern, branching and clustering in a way that is both ordered and unpredictable. Over decades and centuries, it creates a unique and unrepeatable work of art, a living map of the quiet history of that single stone. To look at lichen is to see the result of a million tiny, sensitive decisions, a slow and beautiful dialogue between life and its rugged home. 55. A feedback loop is the engine that can drive a simple system into a state of beautiful chaos. Imagine a microphone placed too close to a speaker. A small sound from the speaker is picked up by the microphone, which then amplifies it and sends it back out the speaker, even louder. This new louder sound is then picked up again, and the system quickly spirals into a loud squeal of feedback. This is a simple runaway feedback loop. In chaotic systems, the feedback is more gentle and complex. The output of the system at one moment is fed back in as the input for the next moment, creating a continuous, self-referential conversation. This process of constantly folding the result back into the cause is what allows the tiny butterfly wings of initial conditions to be amplified, transforming a simple, linear process into a rich, swirling, and unpredictable dance. It is a system talking to itself and creating a world from the conversation. 56. The beautiful Julia set fractals are like a collection of different islands in the same mathematical ocean as the Mandelbrot set. While the Mandelbrot set is one single specific shape, there is an entire infinite family of Julia sets. Each Julia set is generated using the same simple equation, but with a different constant value chosen at the beginning. If the constant you choose is from inside the Mandelbrot set, the resulting Julia set will be a single, connected, and intricate shape. If you choose a constant from outside, the Julia set will be a disconnected cloud of beautiful fractal dust, like a shattered jewel. Each one is a unique work of art, a different what-if scenario in the same imaginative world. They are the countless beautiful children of a single, elegant, and creative mathematical rule. 57. The flow of traffic on a highway can suddenly crystallize from smooth flow into a chaotic traffic jam. When the density of cars is low, the traffic flows freely, like a smooth and predictable river. But as the number of cars increases, the system reaches a critical point. A single driver tapping their brakes for a moment, the butterfly's wing, can set off a chain reaction. The car behind brakes a little harder, and the one behind that harder still, creating a shock wave of slowing that travels backward through the line of cars. The result can be a phantom traffic jam, a region of slow or stopped traffic that persists for hours, even with no accident or obstruction causing it. It is a classic example of complex, chaotic behavior emerging from the simple, repeated interactions of many individual parts, a sudden and frustrating crystallization of motion. 58. The formation of a river delta is a slow and patient act of fractal branching. As a great river approaches the sea, it slows down and deposits the fine sediment it has been carrying. This sediment builds up, blocking the river's path. The river is then forced to split to find new, easier routes to the ocean. These new channels then do the same, depositing sediment and splitting again. Over thousands of years, this simple process of depositing and branching builds a vast, intricate, and tree-like pattern on the landscape. The delta is a fractal, a physical record of the river's long, chaotic search for the path of least resistance. Each delta in the world is unique, a beautiful and muddy signature written by the patient, wandering hand of the water. 59. The gentle, unpredictable flickering of a candle flame is a warm and living chaos. The flame is a column of hot, rising gas, and its shape is the result of a delicate dance between the upward flow of fuel and the turbulent inflow of air. Tiny, invisible drafts in the room, which are themselves chaotic, are enough to cause the flame's shape to shift and sway in a beautiful and unrepeatable performance. It is a system that is stable enough to persist, to continue burning, but sensitive enough to respond to the slightest whisper of the air around it. To watch a candle flame is to watch a small, contained storm of combustion,
a tiny and gentle beacon of beautiful, living chaos that holds the darkness at bay. It is the soft and warm pulse of a quiet room. 60. An ecosystem is held in a state of dynamic, chaotic balance. The populations of different species, the predators and the prey, the plants and the herbivores, are all interconnected in a complex web of feedback loops. A small increase in a prey animal's population can lead to a boom in its predator's population, which in turn will cause the prey population to crash, and so on. These cycles are not simple and regular. They are influenced by the chaotic and unpredictable nature of the weather, the spread of disease, and countless other factors. The result is an ecosystem that is in a constant state of flux, always adapting and changing, but remaining within the bounds of its strange attractor. It is a system that maintains its long-term stability not through rigidity, but through a constant, creative, and chaotic dance of all its living parts. 61. The edge of chaos is where a system has the perfect balance of memory and creativity. In a system that is too orderly, its memory is too strong. It is stuck in a rigid, repeating pattern, unable to learn or adapt. In a system that is too random, it has no memory at all. Each moment is disconnected from the last, and no complex structures can be built. But on the delicate shoreline between these two states, a system can hold on to information and structure from its past while also being flexible enough to incorporate new information and generate novel behaviors. This is the fertile ground where life, intelligence, and computation seem to thrive. It is the place where the thread of the past is woven into the endless possibilities of the future. 62. The way a tree's roots explore the soil is a silent, underground story of fractal exploration. A root grows, seeking water and nutrients, and when it meets an obstacle or a patch of poor soil, it changes direction and branches. This simple process, repeated over and over, allows the root system to efficiently and chaotically explore the vast, complex, and hidden landscape beneath the ground. The final shape of the root ball is a fractal, a unique and unrepeatable record of the tree's long, slow, and sensitive search for sustenance. It is a mirror image of the branches reaching for the sky, one that is written not in air and light, but in darkness and earth. It is the tree's quiet, hidden, and foundational mind. 63. The breaking of a wave on the shore is a beautiful, chaotic, and final act. As a wave travels across the deep ocean, its form is relatively simple and predictable. But as it approaches the shallow water of the coast, it begins to interact with the complex and uneven shape of the seabed. This interaction causes the wave to slow, to steepen, and finally to break in a turbulent cascade of foam and spray. The exact moment and manner of its breaking are chaotic and unpredictable. Two nearly identical waves will break in completely different ways. Each wave is a unique performance, a final, fleeting, and beautiful release of energy that has traveled for hundreds of miles across the sea. It is the ocean's gentle, chaotic, and rhythmic sigh upon the land. 64. The sand pile model shows how complex patterns can arise from the simplest of rules. Imagine a flat table where you are dropping single grains of sand, one by one, onto the same spot. The pile grows, becoming steeper and steeper until it reaches a critical angle. Then, the very next grain of sand can cause a tiny avalanche. This avalanche might then trigger other, larger avalanches elsewhere on the pile. The system, through this simple process, naturally organizes itself into this critical state, always on the verge of a cascade. The size and timing of the avalanches are chaotic and unpredictable. This idea of self-organized criticality is a powerful model for understanding complex systems like earthquakes, forest fires, and even stock market crashes. It is the story of how a system can find its own edge of chaos all by itself. 65. The branching network of our own lungs is a fractal designed for the breath of life. To exchange oxygen with the blood, the body needs an enormous surface area, one that is roughly the size of a tennis court. To fit this vast area inside the chest, the airway branches in a fractal pattern. The single windpipe, the trachea, splits into two bronchi, which then split again and again through about 23 generations of branching, down to the tiny dead-end sacs called alveoli, where the gas exchange happens. This fractal architecture is the most efficient way to distribute the air we breathe to the vast surface area needed to sustain us. Every single breath you take is a journey along this beautiful, silent, and life-giving fractal tree within you. 66. The plot of a familiar and comforting story can feel like a strange attractor. When you reread a favorite book or rewatch a beloved film, you know the overall shape of the journey. You know the beginning, the end, and the major events in between. This is the shape of the attractor. Yet each time you experience it, you notice new things. A small detail, a subtle piece of foreshadowing, a new emotional resonance. Your path through the story is never the exact same twice. You are tracing a new trajectory through a familiar and beloved landscape. The story is a contained world that you can wander through forever, a place that is always predictable in its form, yet endlessly new in its details. It is a safe and beautiful space for the mind to explore. 67. The process of erosion carves fractal patterns into the surface of the earth.
A single drop of rain falling on a hillside will find the path of least resistance downwards. As more drops fall, they begin to carve a tiny channel. This channel captures more water, which gives it more power to erode, carving the channel even deeper. Small channels merge to form larger streams, which merge to form rivers, all in a branching, tree-like, and fractal pattern. Over millions of years, this simple, chaotic process of water flowing downhill can carve the vast and intricate landscapes of canyons and valleys that we see around us. The very face of our planet is a masterpiece sculpted by the patient, fractal, and chaotic artistry of falling water. 68. The beautiful, chaotic patterns of a Jupiter's atmosphere are a symphony of fluid dynamics on a planetary scale. The giant planet is a world of gas with no solid surface. Its colorful bands and zones are jet streams moving at hundreds of miles per hour. And the beautiful swirls and vortices, like the Great Red Spot, are colossal storms that can last for centuries. The movement of this vast ocean of air is a chaotic system, driven by heat rising from the planet's interior and the planet's incredibly fast rotation. The images sent back by spacecraft show a world of breathtaking and intricate beauty, a perfect canvas for the display of chaotic flow. It is like looking at the cream swirling in a cup of coffee, but one that is wider than a dozen Earths and has been gently stirring for billions of years. 69. In chaotic systems, information is constantly being created. In a simple, predictable system, like a swinging pendulum, once you know its initial state, you learn nothing new by watching it. The future is just a simple repetition of the past. But in a chaotic system, because of its sensitivity, every moment reveals new information about its trajectory that you could not have known before. The system is constantly unfolding in a surprising way.
This deep connection between chaos theory and information theory tells us that complex systems are, in a sense, engines of creativity. They are constantly generating new patterns and new information, weaving a story that is always richer in the telling than it was at the beginning. The universe is a fountain of endless, gentle surprises. 70. The way a disease spreads through a population can be modeled as a chaotic process. The initial outbreak may start with a single person, the patient zero. The path the disease then takes depends on a vast number of sensitive and unpredictable factors: who that person interacts with, the density of the population, the patterns of travel, and the small random chances of transmission in each encounter. Epidemiologists use these models to understand how a small localized outbreak can sometimes fade away, and other times explode into a global pandemic. The branching, fractal-like patterns of infection spread are a stark and powerful example of how a tiny, invisible starting point can have profound and world-altering consequences in a large, interconnected system. 71. Our own moods and thoughts can follow a path that feels gentle and chaotic. From one day to the next, your inner state can shift and flow in ways that are not always predictable. A small forgotten memory or a passing sensory experience can be enough to change the course of your thoughts for an entire afternoon. Yet your moods are not completely random. They tend to stay within a familiar landscape, your own personal strange attractor of personality and habit. This inner world is a system of profound complexity, with intricate feedback loops between thoughts, emotions, and the body. To observe your own mind is to watch a quiet internal weather system, with its own calm spells and its own gentle swirling storms, all following a path that is uniquely and beautifully your own.
The quiet, meandering path of a falling leaf is a short and beautiful poem of chaos. As a leaf detaches from its branch, its journey to the ground is not a simple, straight fall. It is a dance with the air. Its broad, irregular shape makes it exquisitely sensitive to the tiniest currents and eddies in the wind. It will rock and flutter and glide, its trajectory determined by a constant, complex interplay with the invisible turbulence around it. Two identical leaves dropped from the same spot at the same time will land in completely different places. Each falling leaf traces a unique and unrepeatable path, a final, graceful, and silent performance before it comes to rest. 73. The irregular, jagged shape of an asteroid tells a story of chaotic collisions. Unlike planets, which are massive enough for their own gravity to pull them into a smooth, spherical shape, asteroids are small, rocky bodies that bear the scars of their history. Their shapes are the result of countless collisions in the early solar system, a chaotic process of chipping, fracturing, and sometimes sticking together. Each asteroid is a unique frozen record of this violent and creative past. Its jagged, fractal-like surface is a testament to the unpredictable nature of these ancient encounters, a silent, tumbling monument to a time when the solar system was a much more crowded and chaotic place. 74. The universe uses chaos to test all the possibilities. A simple, orderly system can only explore a very limited set of behaviors. It is predictable, but it is also rigid and uncreative. A chaotic system, on the other hand, is a natural explorer. By never repeating itself and being sensitive to tiny changes, it is able to wander through a vast landscape of possible states and configurations. This allows nature to find novel solutions to problems. Evolution, for example, uses the chaotic process of mutation to explore the vast space of possible genetic designs.
Chaos is not a flaw in the universe. It is a fundamental feature that allows for creativity, adaptation, and the endless, surprising emergence of new and beautiful forms. It is the engine of cosmic invention. 75. A spider's web is a masterpiece of ordered chaos. Lays down to catch its prey is a more chaotic and adaptive process. The spider adjusts the spacing of the spiral based on its own body size and the tension it feels in the web. The final result is a structure that is a beautiful blend of perfect, repeating order and flexible, adaptive design. It is a physical manifestation of a system that lives on the edge of chaos, combining the strength of predictability with the responsiveness of a more sensitive and creative process. It is a soft, silken net woven with a deep and ancient wisdom. 76. The delicate process of a seed germinating is a journey through a chaotic landscape. For a seed to sprout, it must find a path for its first tender root through the complex and unpredictable maze of the soil. The soil is a chaotic mixture of particles, air pockets, and moisture. The root tip grows, feeling its way, turning to avoid a stone, branching to explore a promising patch of damp earth. Its path is a one-of-a-kind solution to the unique puzzle of its immediate surroundings. It is an act of profound sensitivity and resilience, a tiny, living system navigating a chaotic world to find the sustenance it needs to grow towards the sky. The life of a great tree begins with this first, uncertain, and beautiful journey. 77. The patterns of a city growing over centuries often resemble a chaotic fractal organism. A city does not usually grow according to a single master plan. It expands organically. New roads branch off from old ones, following paths of convenience and geography.
Neighborhoods develop their own distinct character. The result is a complex, living tapestry with a fractal-like structure of main arteries branching into smaller streets, which then branch into tiny alleyways. The city's form is a historical record of countless individual decisions, economic forces, and historical accidents. It is a human-made ecosystem, a beautiful and chaotic structure that is constantly adapting, changing, and growing, a testament to our collective, uncoordinated, and creative energy. 78. Convection cells in a pot of gently heating water show the spontaneous emergence of order from chaos. When the water is uniformly cool, it is still. As you heat it from below, the warmer, less dense water at the bottom begins to rise, and the cooler, denser water at the top sinks to take its place. At a certain critical temperature, this chaotic movement of molecules will spontaneously organize itself into a beautiful, regular pattern of hexagonal cells, a honeycomb of rising and falling currents. It is a perfect example of a system finding a more efficient way to transport heat, creating a higher level of order out of the underlying random motion. It is a quiet, everyday miracle of self-organization, a brief and beautiful geometric pattern born from simple warmth. 79. The gentle chaos in a piece of music is what makes it feel alive. A piece of music that is perfectly regular and predictable, like a simple metronome, quickly becomes boring. A piece that is completely random is just noise. But the music that we love lives in the space between. It establishes patterns and then gently deviates from them. It builds expectations and then playfully subverts them. The rhythm has a subtle human flux, and the melody wanders like a traveler on a familiar road, but one who is free to pause and admire the view. This balance between order and surprise, this feeling of a journey through a strange attractor of harmony, is what engages our minds and touches our emotions. It is the chaotic, beating heart of a beautiful song. 80. The way a rumor or an idea spreads through a social network is a chaotic, branching fire. It begins with one person telling a few others. Some of those people will tell more people, while others will not. The path it takes is highly sensitive to the initial conditions, who starts it and who they are connected to. The idea can branch out like a fractal, reaching vast numbers of people, or it can fizzle out after just a few transmissions. Its journey is unpredictable, following the chaotic and complex pathways of human connection. It is a clear and powerful demonstration of how our interconnected world is exquisitely sensitive to the smallest of starting whispers, and how a single, simple thought can sometimes grow to change the world. 81. A double pendulum is a beautiful and simple machine for creating pure chaos. A regular, single pendulum swings back and forth in a simple, predictable arc. But if you attach a second pendulum to the bottom of the first one, the system transforms. The lower pendulum swings from the bottom of the upper one, and its motion profoundly and chaotically influences the motion of the whole system. The double pendulum will swing and loop in a wild, beautiful, and completely unpredictable dance. Even with no air resistance and no friction, its path is so sensitive to its exact starting position that you can never predict its motion for more than a few seconds. It is perhaps the simplest and most elegant physical demonstration of how easily a predictable system can be tipped over into a world of infinite, looping, and graceful complexity. 82. The patterns of crystallization in a mineral are a frozen record of a chaotic growth process. As a molten rock cools, or as minerals precipitate out of a water solution, crystals begin to form. The final shape and size of these crystals depend on a sensitive dance of factors: the rate of cooling, the pressure, and the presence of chemical impurities. A slight difference in these initial conditions can lead to a vast difference in the final crystalline structure. The beautiful, interlocking, and often fractal patterns we see in a slice of granite or agate are a snapshot of this chaotic process, a story of how a disordered liquid state found its way to a unique and beautiful solid form, written in the language of atoms. 83. The chaotic nature of the atmosphere protects us from a phenomenon called resonance. If the weather were a perfectly periodic, repeating system, then a storm that occurred in the same place at the same time every year could be amplified. The rhythmic pushing could, in theory, build up to catastrophic levels, like a singer shattering a glass by hitting a sustained resonant note. But because the weather is chaotic, it never repeats itself perfectly. It is always slightly different, always out of phase with its own past. This lack of perfect rhythm prevents these destructive resonances from building up over time. The gentle, beautiful unpredictability of the weather is a kind of deep and subtle insurance policy for the stability of our world. 84. The act of learning itself is a journey on the edge of chaos. To learn something new, your brain must be plastic and flexible enough to form new connections and patterns. This requires a certain amount of inherent instability and randomness. However, it must also be stable enough to retain the knowledge it has already acquired. The most effective learning seems to happen in this dynamic state, balanced between forming new, tentative ideas and consolidating old, reliable ones. It is a chaotic process of exploration and reinforcement, a dance between the known and the unknown. Your mind is a living system that thrives on this delicate balance, constantly weaving the threads of new experience into the vast and growing tapestry of your understanding. 85. The strange looping patterns of charged particles trapped in a magnetic field are a form of contained chaos. When a particle like an electron enters a magnetic field, it is forced into a spiral or circular path. In the complex magnetic fields around planets like Earth, these particles are trapped in vast regions called radiation belts.
They bounce back and forth between the magnetic poles, spiraling and drifting in complex, chaotic trajectories. Their motion is a beautiful dance, confined by the invisible, curving lines of the magnetic field, but forever exploring the intricate possibilities of movement within those soft magnetic walls. It is a silent, high-energy ballet performed on a planetary scale. 86. The concept of phase locking is when two chaotic systems can gently fall into sync. Imagine two grandfather clocks hanging on the same wall. If their pendulums are swinging out of sync, the tiny, almost imperceptible vibrations they send through the wall can be enough to slowly nudge them into a state of perfect, synchronized motion. This phenomenon can occur in many chaotic systems. Two nearby fireflies might begin to flash in unison. The cells in your heart's pacemaker synchronize to create a unified beat. It is a beautiful example of how chaotic systems can communicate and cooperate through subtle, gentle influences, creating a higher level of emergent order without any central coordination. It is the universe's quiet tendency to find a shared rhythm. 87. The patterns of oil on a puddle of water are a colorful and chaotic interference pattern. A thin film of oil on water creates a layer of varying thickness. When light hits this film, some of it reflects from the top surface and some from the bottom surface of the oil.
These two reflected waves interfere with each other, canceling out some colors and reinforcing others. Because the film's thickness is constantly changing due to the chaotic swirling of the oil and water, the colors we see are a shimmering, psychedelic map of this fluid motion. You are not seeing pigments in the oil, but rather a beautiful and fleeting painting made of pure light and the chaotic, microscopic topography of a thin, transparent film. 88. A forest fire spreads in a chaotic, fractal pattern across a landscape. The path of the fire is not a simple, advancing line. It is exquisitely sensitive to the chaotic and unpredictable conditions it encounters: the direction of the wind, the moisture content of the trees, and the topography of the land. It will send out sparks that start new, smaller fires ahead of the main front. It will follow ridges and valleys, its edge becoming a complex, fractal boundary of burning and unburned land. The final shape of the burned area is a unique and unrepeatable signature of that one fire, a dark and powerful drawing of the interplay between a simple process and a complex world. 90. The graceful, chaotic motion of a dancer's ribbon creates shapes that exist for only a moment. As the dancer moves, the ribbon trails behind, its path dictated by the dancer's movements and the complex, turbulent flow of the air. It carves beautiful, temporary sculptures in the space around the dancer, shapes that are born and dissolve in a fraction of a second. The ribbon is a visual amplifier of the dancer's gestures, translating them into a larger, more fluid and chaotic language. It is a partnership between human intention and the beautiful unpredictability of the physical world, a fleeting and silent story told in a swirl of colorful silk. 90. The way a mountain range weathers over geological time is a slow, chaotic sculpting process. A young mountain range might have sharp, jagged peaks. But over millions of years, the chaotic and unpredictable forces of wind, water, and ice begin to wear it down. Glaciers carve out U-shaped valleys, rivers create V-shaped canyons, and frost shatters rocks. The final, softened, and rounded forms of an old mountain range are the result of this long and patient chaotic process. The mountains are not static objects, but living systems that are slowly and gracefully responding to the gentle, persistent, and chaotic breath of the planet's atmosphere. 91. The butterfly effect is not about prediction, but about the nature of causality. The idea is not just that we can't predict the tornado, but that the tornado that happens is a fundamentally different one from the one that would have happened without the butterfly. The butterfly's gentle action becomes woven into the causal fabric of the weather, its influence propagating and branching through time. It is a profound statement about the interconnectedness of the world. It suggests that every small action, every quiet gesture, sends ripples out into the world that, in time, can contribute to vastly different outcomes. It gives a kind of quiet significance to the smallest of moments, as each one is a seed for a future that only it can create. The human immune system operates on the edge of chaos to protect us. It needs to be stable enough to recognize the body's own cells and not attack them. But it also needs to be sensitive and chaotic enough to recognize and mount a defense against a near infinite variety of new and invading pathogens. It is a system of incredible complexity and adaptability, a constantly learning and evolving network of cells. Its health depends on this delicate balance.
If it becomes too rigid, it cannot fight off new infections. If it becomes too chaotic, it can lead to autoimmune diseases, where it mistakenly attacks the body itself. Your own well-being is guarded by this beautiful, chaotic, and intelligent dance happening silently within you. 93. The way a cat's purr rumbles in its chest is a subtly chaotic vibration. The sound is produced by the rapid twitching of muscles in the larynx, controlled by a neural oscillator in the cat's brain. This oscillator does not produce a perfectly regular machine-like signal. It has a gentle, chaotic variability to it. This is what gives the purr its rich, living, and deeply soothing quality. You are listening to a biological system that is balanced between order and flexibility, a sound that is both a steady drone and a constantly, subtly changing vibration. It is the gentle, chaotic sound of contentment, a warm and rhythmic expression of a creature at peace. 94. A game of Plinko, where a disc drops through a triangular grid of pegs, is a perfect illustration of emergent order. Each time the disc hits a peg, it has a simple 50-50 chance of going left or right. The path of any single disc is chaotic and unpredictable. But if you drop 1,000 discs, you will find that they distribute themselves at the bottom in a beautiful and highly predictable pattern, the bell curve. The most discs will end up in the central bins, and fewer will be found in the bins towards the edges. This is a profound lesson. Out of the chaos of countless individual, random events, a deep and unshakable statistical order can emerge. The crowd has a wisdom that the individual does not. 95. The branching patterns of a river seen from high above are a fractal map of a watershed. Every drop of rain that falls within a specific area of land will, if it does not evaporate, eventually find its way into the same river. This area is the river's watershed or catchment basin. The boundaries of these basins are often intricate fractal lines that run along the high ridges of the land. A single raindrop falling on one side of this invisible line will end up in one ocean, while a drop falling just an inch away on the other side may end up in a completely different ocean, thousands of miles away. The landscape is a quiet mosaic of these sensitive and beautiful boundaries. 96. The chaotic patterns of evolution show that life is not climbing a ladder of progress, but exploring a vast, branching bush of possibilities. The idea of evolution as a straight line from simpler organisms to more complex ones is a deep misunderstanding. Evolution is a chaotic and contingent process. A small change in the environment, a random genetic mutation, can send a lineage down a completely new and unpredictable path. The history of life is a vast fractal-like tree with countless branches that have flourished and countless others that have become dead ends. We are on one tiny surviving twig of this immense and beautiful bush. There is no inherent direction or goal, only a constant, creative, and chaotic exploration of what it is possible to be. 97. The gentle bobbing of a boat moored in a harbor is a quiet, chaotic response to the sea. The boat is being pushed by two different competing rhythms, the long, slow swell of the ocean waves and the shorter, quicker chop of the wind on the water's surface. The interplay between these forces can create a complex and chaotic motion. The boat will rock and sway in a pattern that never quite repeats, a gentle and unpredictable dance. It is a simple object, caught in the conversation between the wind and the sea, and its motion is the beautiful, non-repeating, and deeply restful result of that quiet dialogue. 98. The beautiful, chaotic curls of steam rising from a hot drink are a final, graceful dance of energy. As the water vapor rises into the cooler air, it condenses back into tiny, visible droplets. This rising plume is a turbulent, chaotic flow, incredibly sensitive to the smallest drafts in the room. It forms the same kinds of intricate whirls and eddies we see in smoke, a silent, white-on-air painting. It is a visual representation of the drink sharing its warmth with the room, a gentle and final exhalation of its heat into the world. It is a quiet, fleeting, and beautiful moment of thermodynamic grace. 99. Chaos theory shows us the immense creativity hidden in simplicity. We have seen again and again how the most intricate, unpredictable, and endlessly fascinating patterns can be born from the simplest of rules, repeated over and over. A short equation can hold an infinite fractal universe. A few simple rules of interaction can allow a flock of birds to create a masterpiece in the sky. This is a deeply hopeful and beautiful idea.
It suggests that the universe does not need an impossibly complex blueprint to create the wonder we see around us. It needs only a few elegant ingredients and the patience of time, allowing them to dance, to interact, and to unfold into a world of infinite, emergent, and gentle beauty. 100. To rest within these ideas is to find a deep peace in the world's beautiful unknowability. Chaos theory does not give us the power to predict and control everything. Instead, it gives us a reason to let go. It invites us to see the world not as a machine to be mastered, but as a living poem to be witnessed. It finds a deep and hidden order in the things we once saw as merely random, and it finds a beautiful, creative freedom in the things we once saw as rigidly determined. It shows us a world that is safe in its patterns, but alive in its endless novelty. It is a quiet permission to simply watch, to wonder, and to be a part of a universe that is forever and beautifully making itself new. 101. The fate of a system is often determined by which gentle valley it chooses to roll into. This idea is known as a basin of attraction. Imagine a vast, dark landscape with several deep, quiet valleys separated by high mountain ridges. If you were to release a small, smooth stone at any point on this landscape, it would gently roll downhill until it came to rest in one of the valleys. The entire region of the landscape from which the stone will end up in a particular valley is that valley's basin of attraction. The ridges that separate them are often intricate, fractal boundaries. A stone placed on one side of the ridge will have a completely different destiny from one placed just a fraction of an inch away on the other side. It is a beautiful and gentle metaphor for how a system's entire long-term future can be decided by its precise starting point, by which silent, downward path it first chooses to follow. 102. The surface of the ocean is alive with the chaotic, fractal dance of countless tiny plankton. These microscopic organisms, the foundation of the marine food web, are not strong swimmers. They are largely at the mercy of the ocean's turbulent currents. The swirling, chaotic motion of the water gathers them into vast, intricate, and ever-changing patterns. Satellite images of the ocean's surface reveal these beautiful, ephemeral blooms as great green swirls and tendrils stretching for hundreds of miles. These patterns have a fractal quality, with smaller eddies and whirls visible inside the larger ones. You are seeing a living portrait of chaos, where the simple physics of fluid motion and the gentle drift of life combine to paint a masterpiece that is wider than a continent, a soft and silent dance between the water and the sun. 103. Every chaotic system has a horizon of predictability, a point in time after which its future becomes a gentle mystery. This timescale is known as the Lionopium time. It is the measure of how long it takes for two almost identical starting points to diverge significantly from each other. For a relatively stable system, like the orbits of the outer planets, the Lionopium time can be millions of years. But for a highly chaotic system, like the weather, it is only a matter of days. After one Lyapunov time, our initial measurements have become so blurred by uncertainty that our forecast begins to lose its connection to reality. It is a gentle and fundamental limit, a quiet reminder that there is a boundary to our knowledge, a beautiful and misty horizon beyond which the future is allowed to keep its secrets, forever new and unwritten. 104. The beautiful, spiraling cones of a Romanesco broccoli are a perfect edible fractal. This wondrous vegetable, a cousin to cauliflower, grows in a pattern that is a breathtaking display of natural, logarithmic self-similarity. The entire head is made up of a large spiral of smaller cones. Each of these smaller cones is, in turn, a perfect miniature replica of the whole head, itself composed of an even smaller spiral of cones. This pattern repeats itself over and over, down to the tiniest, almost invisible scale. It is a three-dimensional fractal, a physical object that seems to have been grown from a simple, elegant mathematical rule. To hold one in your hand is to hold a quiet testament to the way nature uses simple, repeating algorithms to build structures of profound complexity and mesmerizing beauty. It is the gentle architecture of a growing thing. 105. The sound of a gentle rain falling on a roof is a perfect, chaotic symphony. Each individual raindrop is a tiny percussive event, a single note in the larger composition. The timing and location of these notes are unpredictable, governed by the chaotic turbulence of the air through which the drops fall. The result is a sound that is never the same from one moment to the next, yet it is always recognizable as the sound of rain. It is not random noise, but a sound with a deep, soothing structure and texture.
It is a classic chaotic signal, a sound that is balanced perfectly between the monotony of a repeating beat and the incoherence of pure static.
To listen to the rain is to listen to the gentle, rhythmic, and infinitely varied music of the atmosphere itself. 106. The gentle, imperceptible sway of a tall skyscraper in the wind is a chaotic dance on a colossal scale. A skyscraper is not a perfectly rigid object. It is designed to have a certain amount of flexibility to withstand the forces of nature. The wind that pushes against it is a turbulent, chaotic force, with gusts and eddies that are constantly changing. The building's response to this pushing is a complex and chaotic swaying motion, a gentle and slow vibration that is a unique signature of that day's particular wind. Engineers must carefully design the building to ensure that this chaotic motion never settles into a dangerous, resonant rhythm. The silent, invisible dance of a great building is a quiet testament to the constant, gentle, and powerful conversation between a massive human structure and the wild, unpredictable air. 107. The breathtaking, imaginary landscapes in films and video games are often grown from the simple seeds of fractal mathematics. To create a realistic-looking mountain range or a complex alien coastline, digital artists do not have to sculpt every single rock and valley by hand. Instead, they can use fractal algorithms. They start with a simple shape and then apply a simple rule over and over, adding progressively finer layers of random-seeming but structured detail. This process can generate stunningly realistic and infinitely complex terrain that mimics the self-similar roughness of the natural world. It is a beautiful partnership between human creativity and the inherent artistry of chaos theory. The most magical and convincing fictional worlds are often those that have the deep, familiar, and fractal signature of our own. 108. The gentle, rhythmic flapping of a flag in the wind is a simple and beautiful chaotic system. The flag itself is a simple piece of fabric, but it is interacting with the complex, turbulent flow of the air passing around it. As the wind flows past the flagpole, it creates a series of vortices, a swirling wake. The flag begins to flap as it is caught in this unsteady, oscillating current. The beautiful, waving patterns that result are a direct visualization of this invisible dance in the air. The motion is regular enough to be graceful, but chaotic enough that it never repeats itself in exactly the same way. It is a quiet, everyday piece of art, a soft and colorful ribbon that is constantly painting the invisible shape of the wind. 109. The evolution of a living language is a gentle, chaotic, and beautiful drift. A language is not a fixed and static object. It is a living system, constantly being shaped by the millions of people who use it every day. New words are born, old ones fall out of favor, and pronunciations slowly shift over generations. These changes are not planned or directed from a central source. They are the emergent result of countless small, individual interactions, social feedback loops, and historical accidents. The history of a language is a vast, branching, fractal-like tree of dialects and families, a beautiful and unplannable journey. It is a testament to how our collective, chaotic creativity can build structures of immense beauty and complexity without a single guiding hand. 110. Our quiet solar system may once have been a much more chaotic and crowded place. Computer simulations of the early formation of our solar system suggest that there may have been many more small planets and planetary embryos in the beginning, perhaps dozens of them. The early solar system was a chaotic dance of gravitational interactions. Over millions of years, the subtle, repeated nudges between these bodies would have destabilized the orbits of many, flinging them out into the cold of interstellar space or sending them crashing into the sun or the larger planets. The calm and relatively stable arrangement of the 8 planets we see today may be the quiet survivors of this ancient chaotic clearing out, the final, graceful dancers left on a floor that was once much more wild and full. 112. The intricate, 6-sided patterns of an ice crystal are a testament to the power of a simple rule in a chaotic environment. Every snowflake begins its life as a tiny, simple hexagonal prism of ice high in a cloud. As it falls through the atmosphere, it tumbles and drifts through regions of varying temperature and humidity. These chaotic changes in its environment dictate how and where new ice crystals will grow on its 6 corners.
Because all 6 corners experience the same journey at the same time, they tend to grow in beautiful symmetrical patterns. The final, intricate, and unique shape of every single snowflake is a frozen, crystalline diary of its chaotic and beautiful journey from the clouds to the earth. 112. The quiet, fluttering descent of a piece of paper dropped from your hand is a journey of pure chaos. A compact, heavy object falls in a simple, predictable line. But a flat, light object like a piece of paper is a slave to the air. As it falls, it creates its own tiny wake of turbulence, and it is exquisitely sensitive to the tiniest pre-existing currents in the room. It will slide and stall and tumble, its path a unique and unrepeatable performance. You could drop the exact same piece of paper from the exact same spot 1,000 times, and it would never follow the same path twice or land in the same place. It is a perfect, small, and silent demonstration of how easily a simple system can be completely governed by the beautiful unpredictability of the world around it. A system's state space is the vast, invisible library of all its possible futures. Imagine you wanted to describe a simple swinging pendulum. You would need to know its position and its velocity at any given moment. These 2 numbers define its state. The map of all possible combinations of position and velocity is its state space, a simple 2-dimensional plane. But for a complex system like the weather, the state space is a place of almost infinite dimensions, with an axis for the temperature, pressure, and humidity of every single point in the atmosphere. The journey of the system through this immense high-dimensional space is what traces out the beautiful, looping pattern of the strange attractor. It is a way of seeing that even a system with 1 billion possibilities can still be guided by a single, gentle, and beautiful shape. 115. The chaotic dynamics of a crowd of people can form patterns as beautiful as a river. When a large number of people try to move through a space, like leaving a concert, they do not move as a disorganized mob. Without any central direction, they spontaneously self-organize. Streams and lanes of motion form, flowing around obstacles. Gentle waves of density can propagate backward through the crowd, like the phantom traffic jams on a highway. The flow can look remarkably like the turbulent, chaotic motion of a fluid. You are watching the emergence of a collective intelligence, a temporary and beautiful order created by the simple, repeated desire of each person to move forward while gently avoiding their neighbors. It is the quiet, living geometry of a shared purpose. 115. A cat's sensitive whiskers are tools for feeling the chaos of the air. A cat's whiskers are not just passive hairs. They are highly tuned sensory instruments, deeply rooted in nerves that can detect the slightest vibration or touch. As a cat moves through a space, its whiskers can feel the subtle, chaotic turbulence and pressure changes in the air as it flows around objects. This gives the cat a kind of sixth sense, an ability to see in the dark by feeling the shape of the invisible currents. It is a beautiful example of a living creature that has evolved to not just endure, but to masterfully read and navigate the gentle, chaotic, and information-rich world of fluid dynamics. It is a way of listening to the silent language of the air. 116. The final resting place of a bouncing ball is a quiet, chaotic secret. If you drop a perfectly uniform ball onto a perfectly flat surface, its bounces will be simple and predictable. But in the real world, the surface is never perfectly flat, and the ball is never perfectly uniform. If you drop a ball with a slightly irregular shape, like a football, onto the ground, its bounces are a chaotic and unpredictable dance. The way it will ricochet depends with exquisite sensitivity on the exact angle and point of its impact with the ground. You can watch it bounce a dozen times, but you will never be able to predict with certainty where its final, quiet resting place will be. Its journey is a short, energetic, and beautiful conversation with uncertainty. 117. The gentle, swirling patterns you create when stirring a pot of soup are a universe of chaotic mixing. With each slow turn of the spoon, you are performing a simple act of stretching and folding the fluid. 2 drops of liquid that start out side by side will be pulled apart, stretched into long, thin filaments, and folded back into the mixture. After just a few stirs, they will be in completely different parts of the pot. This is the same chaotic principle that bakers use to knead dough. It is an incredibly efficient way to blend ingredients, using a simple, repeated motion to create a smooth and uniform result from a lumpy, separated start.
It is a quiet, domestic, and deeply satisfying form of applied chaos theory. 118.
The wild heart of a chaotic system can sometimes be tamed with a single gentle touch. This is the surprising and hopeful idea of control of chaos. Because chaotic systems are so sensitive to small perturbations, it means that a tiny, carefully timed nudge can have a very large effect. Scientists have discovered that by applying a series of these small, intelligent kicks, they can stabilize a chaotic system, forcing it to follow one of the simple periodic orbits that are hidden within its strange attractor. It is like gently guiding a wild horse onto a smooth and easy path. It suggests that we don't always need immense force to influence a complex system, but rather a deep understanding and a gentle, responsive, and perfectly timed hand. 119. A great river network seen from high above the Earth is the planet's most patient fractal drawing. Over millions of years, the simple, persistent action of water flowing downhill has carved a magnificent tree-like pattern into the landscape. Small, high-altitude streams, the finest twigs of the system, gather into creeks. The creeks flow into larger streams, the branches, which in turn flow into the great river itself, the trunk. The entire structure, from the smallest rill to the final delta, exhibits a beautiful, self-similar and fractal geometry. It is like gently guiding a wild horse onto a smooth and easy path. It suggests that we don't always need immense force to influence a complex system, but rather a deep understanding and a gentle, responsive, and perfectly timed hand. 119. A great river network seen from high above the Earth is the planet's most patient fractal drawing. Over millions of years, the simple, persistent action of water flowing downhill has carved a magnificent tree-like pattern into the landscape. Small, high-altitude streams, the finest twigs of the system, gather into creeks. The creeks flow into larger streams, the branches, which in turn flow into the great river itself, the trunk. The entire structure, from the smallest rill to the final delta, exhibits a beautiful, self-similar and fractal geometry. It is a perfect physical record of the most efficient network for draining the water from the land, a design discovered not by a conscious mind, but by the slow, gentle, and chaotic persistence of gravity itself. 120. The silent, swirling dance of dust motes in a sunbeam is a window into the hidden chaos of the air. The tiny, almost weightless particles of dust are perfect tracers, revealing the invisible movements of the room's atmosphere. The air, which seems so still to us, is in a constant state of gentle, chaotic motion, driven by tiny differences in temperature and pressure. The dust motes are carried along on these currents, their paths a complex and beautiful ballet of rising, falling, and swirling. To watch them is to be given a rare glimpse into the secret, turbulent life of the stillness around you, a quiet and mesmerizing performance that is happening in every sunlit room, all the time. 122. The beautiful, flowing patterns in a piece of wood grain are the frozen diary of a tree's chaotic growth. The lines and swirls show the layers of growth from one year to the next. The shape of these rings is not perfectly uniform. It is a sensitive record of the tree's life, influenced by the chaotic and unpredictable nature of its environment. A wider ring tells of a good year with plenty of rain, while a narrow one speaks of a drought. A knot in the wood is the ghost of a branch, and the way the grain flows around it is a picture of the tree adapting its own structure. To look at the grain of a wooden table is to read a silent, beautiful, and centuries-long story of a living thing's gentle, chaotic, and resilient dance with the sun and the seasons. 122. The spacing of trees in a wild old-growth forest is a pattern of beautiful and deep chaos. The trees are not planted in neat rows, nor are they scattered with pure randomness. The final pattern is the result of a long and complex history. It depends on where the seeds happen to fall, a chaotic and unpredictable event. But it also depends on a process of competition as the young trees vie for sunlight and water. This creates a pattern that has a deep structure, a kind of anti-clustering that ensures the trees are not too close together. The forest is a living, fractal mosaic, a beautiful and complex design that has been slowly and patiently optimized by the interplay of chance and necessity over hundreds of years. 123. A great school of fish moving through the ocean is a single, shimmering, and intelligent fluid. Like a flock of starlings, the school has no leader. Each fish follows a simple set of rules, primarily reacting to the position and velocity of its nearest neighbors. This simple local interaction is enough to create the stunning, coordinated, and instantaneous movements of the entire group. They can split around a predator and reform in a fraction of a second. The school is a living example of a decentralized, self-organizing, and chaotic system that exists on the edge of chaos. It is a single, liquid mind made of 1,000 smaller bodies, a beautiful and silent testament to the wisdom of the collective. 124. The wobbly, uncertain path of a single air bubble rising through water is a simple, chaotic journey. A very small bubble will rise in a straight line, but a slightly larger bubble becomes unstable as it rises. Its shape deforms, and it begins to follow a zigzagging or spiral path to the surface. Its motion is a complex interplay between its own buoyancy and the chaotic, fluid wake it creates behind itself. This wake then influences the bubble's subsequent motion, a constant feedback loop. Two bubbles released from the same point at the bottom of a glass will take wildly different paths to the top. Each one is on its own private, silent, and beautifully unpredictable pilgrimage to the air. 125. The kicked rotor is a physicist's beautifully simple thought experiment for exploring chaos. Imagine a simple spinning stick, a rotor, that is completely frictionless. On its own, it would just spin at a constant speed forever. Now, imagine that at perfectly regular intervals, you give it a gentle, identical kick. This simple periodic nudge is enough to transform the system into one of profound chaos. Depending on the exact position of the rotor when the kick arrives, its speed will change in a complex and unpredictable way. After many kicks, its final speed is impossible to know. It is a perfect, stripped-down example of how a simple, deterministic, and repeating action can generate behavior that is, for all practical purposes, completely random and unknowable. 126. The slow, patient dripping of a candle creates a unique and beautiful sculpture of solidified wax. As the candle burns, a pool of molten wax forms at the top. Sometimes, a drip will escape and run down the side. The path this drip takes is chaotic and sensitive. It is influenced by the exact shape of the candle at that moment and by the subtle drafts of air in the room. As the drip cools and solidifies, it changes the landscape for the next drip, which will then follow its own new path. Over the course of hours, this simple, repeated process builds a one-of-a-kind cascade of frozen rivers of wax. The final shape is a silent, beautiful, and unrepeatable record of the candle's long and quiet life. 127. A simple game of billiards is a system of beautiful, high-speed chaos. When you strike the cue ball, you send it on a mission. Its first collision with another ball seems simple enough. But the outcome of that collision depends with exquisite sensitivity on the exact point of impact. A difference of a micron can change the resulting angles by a significant amount. After just a few collisions, the system becomes completely unpredictable. The gravitational pull of a person walking past the table is theoretically enough to change the outcome of the game. It is a perfect, small, and contained example of how quickly uncertainty can grow in a system of interacting parts, transforming a simple starting action into a beautiful, complex, and unrepeatable cascade of motion. 128. The beautiful, branching patterns of cracks that form in drying mud are a slow-motion fractal explosion. As a patch of wet mud dries in the sun, it shrinks. This shrinking creates tension in the surface. At a certain point, this tension is released as a crack. This first crack relieves the stress in its immediate vicinity, which influences where the next crack is most likely to form, often branching off from the first one. This process continues, creating the beautiful, polygonal, and fractal patterns we see in a dried-up riverbed. The final pattern is a unique signature of that particular patch of mud and the way it dried, a quiet and earthen map of a slow and gentle release of tension. 129. The shifting, colorful patterns on a chameleon's skin are a living, breathing, chaotic display. A chameleon changes its color not with pigments, but with tiny, specialized skin cells that contain nanocrystals. By adjusting the spacing between these crystals, the chameleon can control which wavelengths of light are reflected. The control of this system is a complex, chaotic process, allowing the chameleon to produce an incredible variety of patterns for camouflage, communication, and regulating its temperature.
The beautiful, flowing, and sometimes psychedelic displays are a living example of a biological system that has harnessed the power of chaos to create a dynamic, adaptive, and truly wondrous form of art. 130. The silent, dancing curtains of the aurora are a celestial painting of beautiful chaos. The northern and southern lights are caused by charged particles from the sun, the solar wind, being guided by the Earth's magnetic field into the upper atmosphere. The flow of these particles is turbulent and chaotic. The Earth's magnetic field is also a complex and dynamic thing. The interplay between these two chaotic systems is what creates the beautiful, shimmering, and ever-changing shapes of the aurora. The graceful, silent motion of the glowing curtains of light is a direct visualization of a vast and complex physical process, a gentle and unrepeatable light show that connects the heart of our sun to the thin, high air of our own quiet planet. 131. The gentle decay of a mountain echo is the sound of chaos. When you shout into a valley, the sound wave travels out, and what you hear as an echo is the sound reflecting off the complex, distant surfaces. The mountainside is not a simple, flat wall. It is a rough, fractal surface of rocks and trees. The sound wave scatters off this complex shape in a chaotic way. The clear initial echo quickly dissolves into a soft, prolonged reverberation as the sound bounces around in a complex and unpredictable dance. You are hearing the sound wave slowly losing its coherence as it interacts with a beautiful and disordered world. It is the gentle and audible process of a simple sound dissolving into the landscape. 132. A simple act of stretching and folding is the secret heart of all chaotic mixing. The mathematician Stephen Smale imagined a simple process called the horseshoe map. You take a square of a soft, pliable material, stretch it out into a long, thin rectangle, and then fold it back on itself into a horseshoe shape, placing it back over the original square's area. If you repeat this process over and over, you will find that 2 points that started very close together are rapidly separated and end up in completely different parts of the square. This simple geometric action is the fundamental mechanism that underlies all chaotic systems. It is the gentle engine that takes small uncertainties and stretches them until they are as large as the entire world. 133. The seemingly random pattern of craters on the moon is a quiet history of cosmic chaos. Over billions of years, the moon has been bombarded by asteroids and comets. The timing and location of these impacts are a chaotic and unpredictable process. The resulting landscape is a beautiful, fractal tapestry of overlapping circles of all different sizes. While the process is chaotic, it is not purely random. Larger impacts are rarer than smaller ones, which gives the overall pattern a deep statistical structure. To look at the face of the moon is to look at a silent, preserved record of the solar system's long and chaotic history, a gentle, pockmarked testament to 4 billion years of quiet, cosmic reign. 134. The gentle, ever-changing motion of a mobile sculpture is a quiet dance with chaos. A mobile, like those created by the artist Alexander Calder, is a system of balanced, weighted shapes connected by wires. It is designed to be exquisitely sensitive to the gentlest of forces. The tiny, chaotic currents of air in a room are enough to set it in motion. Each element turns and sways, its movement influencing all the others in a complex and unpredictable feedback loop. The result is a sculpture that is never the same from one moment to the next, a piece of art that is constantly recreating itself in a silent, graceful, and never-repeating performance. It is a machine for turning the invisible chaos of the air into visible beauty. 135. The patient, searching path of a vine growing up a wall is a living line of chaos. The tip of a growing vine is not following a predetermined plan. It grows and gently circles, a process called circumnutation, as it feels for a place to grip. Its path is a chaotic exploration of its immediate environment. It is sensitive to the texture of the wall, the direction of the sunlight, and the presence of obstacles. The final, beautiful pattern of the vine covering an old building is the frozen record of this long and sensitive search. It is a unique and unrepeatable story of a living thing's slow, persistent, and successful journey through a complex and challenging world. 136. The sudden emergence of a new thought can feel like an island rising from a chaotic sea. Our brain is a system of billions of interconnected neurons firing in complex, chaotic patterns. Our conscious mind seems to float on the surface of this vast and turbulent ocean of activity. A new idea,
A sudden memory or a creative insight often emerges into our awareness without a clear and logical preceding step. It can feel like a moment of spontaneous creation, a novel pattern of thought suddenly crystallizing out of the deep and beautiful chaos of our own neural network. It is a quiet and profound reminder that our own creativity is born from a process that is far deeper, wilder, and more mysterious than our conscious self can ever fully know. 137. A simple kaleidoscope creates a universe of beautiful, ordered chaos. The device is simple, 2 or more mirrors angled towards each other in a tube with a collection of loose, colored objects at the end. The mirrors reflect the random arrangement of the objects into a beautiful, symmetrical, and repeating pattern. Each tiny, chaotic shift of the objects at the end, a slight turn of the wrist, creates a completely new and equally beautiful symmetrical world. It is a perfect metaphor for how a simple set of rules, the laws of reflection, can take a disordered, chaotic input and transform it into a vision of profound and breathtaking order. It is a small, handheld machine for turning randomness into art. 138. The adjacent possible is the gentle, chaotic frontier where all new things are born. This is the idea that creation, whether in biology or technology or art, does not happen by giant leaps into the completely unknown. It happens by a chaotic and exploratory process of combining what already exists in new and surprising ways. At any moment, there is a set of possibilities that are just one step away from what is currently real. Evolution, for example, cannot invent a wing from nothing. It must tinker chaotically with a pre-existing limb. A new idea is a new connection between old ideas. Creativity is the gentle, chaotic, and often accidental process of wandering along the edges of the known world and discovering the new doors that have just become unlocked. A great kelp forest sways in the ocean's currents in a slow and beautiful chaotic rhythm. Each long frond of kelp is anchored to the seabed, but its body is free to be moved by the water. The ocean's currents are turbulent and chaotic, especially near the shore. The entire forest of kelp sways in a complex and mesmerizing dance, each plant responding to the water's push in its own way, yet all moving as part of a larger, coherent, but never repeating pattern. To watch it is to see a living, underwater forest breathing with the slow, powerful, and chaotic lungs of the sea itself. It is a silent, graceful, and deeply peaceful dance of life and water. 140. The unpredictable chiming of an old, worn clock is the sound of gentle chaos. A new clock is a model of perfect, predictable order, its gears meshing with precision. But over many decades, the gears wear down. Tiny, microscopic imperfections develop. A little bit of friction is introduced here, a slight wobble there. The clock's mechanism becomes a chaotic system. It may still keep time reasonably well, but the exact moment of its chime and the quality of its sound can become subtly unpredictable. It is no longer a perfect machine, but something more organic and characterful. You are hearing the gentle and beautiful signature of a long life, a quiet story of the slow, inevitable, and graceful drift of all things from perfect order into a softer and more interesting state. 141. The mixing of 2 colors of paint on a palette is a small, beautiful, and chaotic dance. When you place a blob of blue next to a blob of yellow, they are separate. But as you begin to stir them with a brush, you are performing a chaotic act of stretching and folding on a microscopic scale. Thin filaments of each color are stretched out and folded back on each other, over and over. The beautiful, swirling patterns of green that emerge are a visual record of this chaotic mixing process.
For a few moments, before the color becomes uniform, you can see the intricate fractal-like boundaries between the colors, a tiny and temporary masterpiece of fluid dynamics created by a single gentle gesture. 142. The 4 tiny moons of Pluto are locked in a complex and chaotic celestial dance. Unlike most moons in the solar system, which have simple, predictable orbits, Pluto's small moons, Styx, Nix, Kerberos, and Hydra, are tumbling and wobbling in a state of chaos. They are all being influenced by the strange, shifting gravitational field created by the double planet system of Pluto and its large moon Charon, which orbit each other like 2 ends of a spinning dumbbell. The gravitational environment is so complex that the small moons cannot settle into a simple, stable rotation. They are another beautiful example of the 3-body problem in action, a quiet and distant reminder that the heavens are filled with wild and untamed beauty. 143. A crumpled piece of paper is a simple object that contains a universe of fractal complexity. When you crush a sheet of paper into a ball, you create a complex network of creases and ridges. Studies have shown that the statistics of this network have a fractal structure. The ball is not a solid object, it is mostly empty space, and the crumpled paper forms a kind of rigid skeleton. This structure is incredibly strong for its weight. It is a beautiful, everyday example of how a simple, chaotic action can create an object with profound and surprising geometric properties. It is a small and humble testament to the deep and intricate patterns that can be born from a moment of simple, disordered action. 144. The meandering, unpredictable path of a single tear is a quiet and chaotic journey. As it leaves the eye, its path down the cheek is not a straight line. It is a tiny river, and its course is exquisitely sensitive to the microscopic, chaotic topography of the skin.
It will follow the path of least resistance, diverting around tiny ridges, and sometimes splitting into two separate streams. Its journey is a unique and unrepeatable line, a gentle and silent map of a complex and invisible landscape. It is a simple physical process, yet one that is imbued with a deep and quiet poetry, a fleeting and personal expression of a universal human experience. 145. A sandy shoreline is a living, breathing line that is forever being redrawn by chaos. The boundary between the land and the sea is never a static, fixed thing. It is a dynamic interface, constantly being shaped by the chaotic and unpredictable action of the waves, the tides, and the wind. A single storm can move tons of sand, erasing a part of the beach and building a new sandbar somewhere else. The shape of the coastline is a fractal, a beautiful, jagged line that is always in a state of gentle, creative flux. It is a perfect physical metaphor for a boundary that is not a wall, but a constant, ongoing, and beautiful conversation between two different worlds. 146. A child's finger painting is a masterpiece of joyous and beautiful chaos. When a child dips their hands in paint and moves them across the paper, they are not following a set of rules or a preconceived plan. They are engaging in a process of pure chaotic exploration. They are feeling the texture of the paint and seeing the beautiful swirling patterns that emerge from their own simple gestures. The final painting is a direct and honest record of this creative and chaotic process. It is a celebration of the beauty that can be found when we let go of control and allow ourselves to play in the rich and unpredictable space of pure possibility. 147. The dramatic death of a star as it is torn apart by a black hole is a final chaotic symphony. When a star wanders too close to a supermassive black hole, the immense tidal forces begin to stretch it. The side of the star closer to the black hole is pulled much more strongly than the far side. The star is drawn out into a long, thin stream of hot gas, a process called spaghettification. This stream then wraps around the black hole in a complex and chaotic dance, forming a temporary glowing accretion disk before it is finally consumed. This violent and beautiful event, a tidal disruption event, is a final, brilliant flash of light from a dying star, a final and chaotic masterpiece painted on a galactic scale. 149. The shimmering, dancing light on the surface of a swimming pool is a living map of chaos. The surface of the water is never perfectly flat. It is a complex, moving landscape of tiny, chaotic waves and ripples caused by the wind and the water's own gentle movement. As sunlight passes through this uneven surface, it is refracted and focused in a complex way. The beautiful, shimmering network of bright lines that we see on the bottom of the pool is a direct visualization of this chaotic process. It is an ever-changing, intricate web of light, a gentle and mesmerizing projection of the invisible and beautiful chaos happening on the water's surface. 149. The strange, winding path of a dream is a story told by a chaotic mind. When we sleep, the logical, linear part of our brain rests, and our mind is free to wander through its vast associative network of memories and emotions. The narratives of our dreams are not bound by the simple rules of cause and effect. They are chaotic and beautiful constructions, where places and people can transform in an instant, and the story can leap from one strange scene to the next without warning. A dream is a nightly journey into the deep, creative, and chaotic heart of our own consciousness. It is a private and personal work of art, created fresh each night from the beautiful, unpredictable, and mysterious stirrings of our own sleeping mind. There is a gentle and profound peace in accepting the universe as a beautifully imperfect and creative place.
chaos theory teaches us that the world is not a rigid, predictable machine, but a living, breathing system that is constantly unfolding in new and surprising ways. It finds a deep and hidden order in what appears to be random, and it reveals an infinite creative freedom within the simplest of rules. To embrace this is to let go of the need for perfect certainty and to find joy in the wonder of the unknown. It is to see the universe not as a puzzle to be solved, but as a poem to be read, a song to be heard, and a beautiful, gentle, and chaotic dance that we are all a part of. And so our gentle wandering through the beautiful, swirling patterns of the world begins to slow. The intricate coastlines we explored soften into a single quiet shore, and the countless branching rivers we followed now flow together, merging into a great and silent ocean of stillness. The quiet hum of the universe's hidden rules fades into a peaceful, deep silence, and there is nothing left to do now but float weightlessly in the calm and quiet space that remains. We have drifted on the softest of currents tonight, listening for the quiet poetry that hides within the heart of the world. We have felt the profound and gentle truth that the flutter of a butterfly's wing is woven into the fabric of a distant storm, that all things are connected by invisible and delicate threads. We have wandered through the infinite, feathery landscapes of fractals, discovering that a single simple thought can blossom into a universe of endless and breathtaking beauty. We have seen how the patient branching of a tree, the jagged path of a lightning bolt, and the slow crystalline growth of a snowflake are all different verses of the same silent cosmic poem. We have learned to see the world not as a perfect and rigid clockwork machine, but as a living, breathing work of art, one that is forever creating itself, forever unfolding in new and gentle surprises. And you are a part of this beautiful, unpredictable dance. The very rhythm of your own heart, beating softly and steadily in your chest as you rest, is not the rhythm of a machine. It is the gentle, chaotic, and living pulse of a healthy system, one that is always adapting, always responding, and always alive with a deep and subtle music. The quiet and steady breath that fills your lungs travels through a beautiful, branching fractal tree, a design perfected by life to carry the air to every part of your being. The intricate network of your own blood vessels is another silent fractal river flowing with a quiet and life-giving purpose. Even the wandering, gentle flow of your thoughts as you begin to drift now from one idea to the next is its own strange and beautiful attractor, a familiar and safe landscape for your mind to explore as it prepares for rest. You do not need to be perfect or predictable. Your own beautiful human nature is one that thrives on that gentle edge of chaos, a place of creativity, of resilience, and of quiet, profound peace. You are a living piece of the universe's poetry, a pattern that is at once ordered and forever new. So now, let the need to follow any pattern at all simply dissolve. Let go of the journey and allow yourself to settle into the deep and restful destination of sleep. There are no more paths to trace, no more beautiful shapes to see. There is only the soft, quiet darkness and the feeling of being held and supported. Allow your mind to become like a single, quiet pool of water, its surface growing still and smooth, reflecting nothing but the peaceful dark. If any final thoughts arise, let them be like single leaves falling gently onto this quiet water and drifting, without effort, to the distant shore of your dreams. There is nothing you need to do. There is nothing you need to hold on to. Your only task now is to let go, to soften, to drift. May your sleep be deep and dreamless, a quiet and restorative journey into the heart of stillness. May you rest, and may you be at peace. Sleep now. Good night.